Okay, good morning, everyone. How did the homework go? Do you guys have any questions about the homework? Please get going. Ooh. Okay, as usual, I'll pick some. I don't do every one of them. So we'll do look at 25 and 35 and 37. Okay. All right. Now 35 I've done a lot, so I will just pick the 25 and the 37. So 25 is the following. We have f of x equal one over x plus 1 and a equal minus a half. Okay, so this is the question. We have this function, and the first question is they want us to find the derivative in general. So they don't want us to find it at a specific point because, as we said last time, they don't want us to repeat the same process over and over. So the first step is to find the derivative in general for any x. And then we zoom in at a specific point. So if I want to find it for every x, let us remember what's the formula for it. In general. What do you want me to, which one would you want me to use? The one with h or without h? Anybody has any preference? Suppose I use the one with h. What does the formula tells me? You take the difference quotient. It means you take f of x plus h minus f of x. You divide it by h, and then you let the h goes to 0. So that's the process. So this is my function, 1 over x plus 1. Should look something like that. That's the function, and that's a point x. And then this is the point which is very close to x. The f of x plus h minus f of x represent the slope of the line here. And then we let the h goes to 0, we get to the tangent line. That's always in the picture. So now we just have to plug in and proceed. Okay, 1 over, let's see how we plug in carefully. Whenever there is x, I put x plus h. So I will have x plus h plus 1 minus. Whenever there is x, I put that's x plus 1, the whole thing divided by h. And the question is, we have to find the limit. All right, to find the limit here, we have to find a common denominator. I mean, we cannot guess anything. We have to take the piece here, this one, and find a common denominator. So my common denominator here is the product. That's the common denominator divided by h. And now for this piece, I need to multiply by x plus 1. For that, I have to multiply by x plus h plus 1. And now we just have to basically simplify this expression and hopefully find the limit. So this will give me the limit as h goes to 0 of divided by h. Now h is over 1. It's like multiplying by 1 over h. The denominator is x plus h plus 1 times x plus 1. Okay. And now let us deal a little bit with this piece here. What's this piece here? Okay, I'm going to simplify it right there. Let's see what this piece is. Is x plus 1. I distribute the minus x minus h minus 1. So the numerator become plus x become minus h. So we're doing well. The h will simplify because it's part of a product, and I will end up with the limit as h goes to 0 of a minus 1 over this whole quantity up here. Now what happens when h goes to 0? When h goes to 0, this expression here, h become close to 0, will become close to x plus 1. And there is no h. So this is x plus 1. So x is fixed in this scenario. X is fixed, h vary. So when h takes value close to 0, this will become close to 1. And this gives me 1 over the quantity x plus 1 squared. So what's the benefit of this? This gives me a formula. So I can find the slope of the tangent now at any point I want. So now I know the formula. So for every x, no matter what x is, the slope is 1 over x plus 1 squared, no matter what x is. Now, they want me to find f prime at very specific point. It means when a equal minus a half. So it means they want me to find f prime at minus a half. Now it's nothing more. I don't have to repeat the process anymore because it's the same thing. So instead of x, it's minus a half. But now I don't need to repeat the process. I just plug in minus a half in the formula. And I will have minus a half plus 1 squared. Now minus a half is a half. So it's going to be minus 1 over a half squared, which would give me minus 4. Okay, so now any point on the graph of the function would look something like that. Any point, we are able to find the derivative at any point. So minus a half was here. So what we found is the slope here. That's my slope. The slope here is minus 4. I don't have to repeat. Now I have a formula for it. All right. Before I move on to 37, any questions before we proceed? Question, guys? Okay. Let's move to 37. Because it's a bit harder than 35. That's why I'm doing 37. So 37. And the question is basically find a formula and then find the equation at the given point. So here my function is the square root of 3x plus 1. So the first question is find a general formula, and then they want me to find the slope at a equal 8. Okay, we keep that later. So question number 1 is find a formula for f prime. So find the rule that if I know x, I know f prime. That's what finding a formula is. Again, it's the same process. I mean, what matters for me is that you guys can set it. So what is f prime of x? F at x plus a little bit minus f of x over h. And then once we do that, we let h goes to 0. Right, now you help me out with the setting. So that's the limit as h goes to 0 of what's f of x plus h? What's f of x plus h? Square root of. What does f do? Take the square root of 3. Instead of x, I have x plus h. So every time I have x, I put x plus h plus a 1 minus 3x plus 1 over h. The setup is crucial. The setup is crucial. Now, when h goes to 0, what's really happening? Denominator go to 0. The numerator is h goes to 0. I will be left with square root of 3x plus 1 minus the square root of 3x plus 1. So when h goes to 0, we have 0 over 0. We are in trouble. So how can we get rid of that? And this is a scenario that we've seen. Okay, what you guys remind me, what shall I do? We've done this before. Okay, remember guys how we get rid of this 0 over 0 scenario in this problem. multiply by a conjugate. So that's really the trick that we used before. So that's why, okay, we multiply by the conjugate, numerator and denominator. Okay, so this is 3x plus 1. That's 3 times x plus h plus 1, 3 times x plus h plus 1. Okay. So that's the trick we use to help us actually solve this problem. And let's see what we have now. Okay, so this is a minus b times a plus b. And now we're going to have a squared minus b squared over the same quantity. Okay, so squaring, it means get rid of the square root. So I will have 3x plus 3h minus 1. So this is going to go now. And then this will go and would leave me with 3x plus 1. Let us collect everything and see what we get. All right, the numerator. 3x minus 3x, they will cancel each other out. Plus 1 minus 1 will cancel. I will left with 3h. Somehow the h has to go, but it has to go algebraically in a correct way. We cannot just get rid of it. So algebraically, we have to do it correctly. And now this is going to give me plus. Okay. Now h is, and of course h goes to 0. All right, so now what will going to happen? So now I don't have my h. I will have the limit of 3 over this plus that. That's give me 3x plus 3h plus 1, 3x plus 1. My h goes to 0. Very good. So this is equal to what finally? When h becomes very small, x is fixed. X is not changing. It's the h that's changing here. When h goes to 0, this will go to 0. So I will have 3 over the square root of 3x plus 1 plus the square root of 3x plus 1. This is exactly the same term. So I'm going to have 3 over 2 times the square root of 3x plus 1. And this is give me the formula for the slope at any x. So now f changes. As f changes, the slope changes. So now we have a new function that for every x, I know the slope of the tangent. And that's the slope of the tangent for any x. Now our problem will become easier because now they want me to find the equation at a very specific point. So now I have the formula. The question is become easier. So now this is my function, the square root of 3x plus 1. It's going to look something like that. So this is f of x equal the square root of 3x plus 1. That's my function. I have a point A, which is equal to 8. And then at this point, this is my function. I have a slope. I have a line, the tangent line. And the question is find the equation of the tangent line. So how do we find the equation? So now equation of the tangent line at a equal to 8. Okay. Again, to find the equation, we need two things. We need a point and we need a slope. Now, do we have a point? Do we have a point? Do we have a point? Yes or no, and what it is?
Yes.
Give me the point.
8 over, once you put the 8 into the equation we just got.
Exactly. That's A. What's this point here? That's 8. And that's the square root of 3 times 8, 24 square root of 25. So the point is A, F at 8. So they're not going to give you f of 8 anymore. We have to do it. So this is going to give me the point 8. F of 8 is 5. I have the point. Now the slope. The slope is the derivative at 8. So instead of x here, I'm going to put 8. So this is going to give me 3 over 2, the square root of 3 times 8 plus 1. I don't have to repeat the process now because I have a general formula for every point, which is 3 over, that's 5, 3 over 10. And now we're done. So once we have this, we're actually, the problem simplifies. So now the equation will become the following. Y minus 5 equal 3 over 10 x minus 8. Okay, and then the rest we just simplify a tiny bit. Usually if you leave it like this, it's fine with me. I don't, personally, I'm all right with it, but I think my lab wants you to simplify it. So this would give me 8, that's a 4, and that's a 5, 12 over 5, plus 5, I think, unless I'm doing a stupid mistake here, minus 12, common denominator, which is minus 12 over 5 plus 25 over 5. So I end up with 3 over 10x plus 13 over 5. And of the problem. Okay. All right. Any questions? 35 is easier, so you should be able to do it because I did basically the same thing last time. Okay, so today, of course, we're going to keep along the same line. That's what we will be doing most of this semester anyway. So today we're going to start graphing a little bit the derivative. So what we did so far is we actually found a formula for it. So what we did now is the following. We have a function. We have that. And instead of finding the slope at every point, we found really a general formula. And we realized that, you know, this is the general formula. And starting next section, we're going to learn basically how to find those formulas without having to do the limit process, which is, of course, is a long process. But today we're going to think graphically, a little bit graphically, more than algebraically. So I'll start with simple example, some example, basic example. Actually, this one I'm going to do it also algebraically. And then I start graphically. Suppose I have a function. That's my function. And my function is constant, doesn't change. So this is the graph of f of x. So this is c. So f is constant. It doesn't change. The value do not change. What is the derivative in this scenario for any point? I mean, what's the formula for the derivative? 1, no, at 1, it is 0. Why it is 0? Let us see what the derivative is. The derivative is, let me take any point x. So two things you can think about it. First, if I take any point x, what does the derivative involve? What does the derivative involve? At any x, you take a point next to it, and you compute the change of the output. But here, suppose I take the change. So that's the change of the output. You divide it by the h. But in this case, what's the change? What's the slope here, basically? The slope is, the function is not changing value. So it's 0 over 0. This is equal to 0. So as a function is constant, does not change at all, the derivative is always 0 because given any point, if you take one next to it, the slope here is 0. The value is not changing. Okay, so that's the first situation. So if my function f of x is a constant, I'll write it in words. It means there is no change, like f of x equal 2 all the time, f of x equal 3 all the time, and then the derivative is always equal to 0 because there is no change in the output. So when I'm trying to compute change of output over change in input, I definitely get 0. So those are the very, very basic case. Another basic case, which is also we should absolutely know, is the following. Suppose my function f happen to be a straight line. Okay, a straight line. And let us assume that this is a straight line with slope. So that's a straight line, it has a slope. Let us assume I'm giving you a formula now, 2x plus 4. Okay, I don't have to give you, but 2x plus 4. Okay, so that's the function. What is the derivative in this scenario for any x? So any x, okay, and I need to find the derivative. What's going to be the derivative if the function is a straight line? If that's crucial. Okay, everybody telling me 2 because everybody is correct. And the idea is because algebraically or graphically, I have to take a point next to it. That's my x plus h. And if I compute the change over the change, that's a straight line. I'm going to get, honest to goodness, it. So that's graphically. Now, if you do it algebraically, again, it's the same thing. F at x plus h is 2 times plus 4. So instead of x, I have to put the x plus h minus f of x, which is 2x plus 4 over h. I'm basically computing the slope here. So this will give me the limit of 2x plus 2h plus 4 minus 2x minus 4 over h. 4 and 4 simplify, minus 2x plus 2x simplify, and I will have the limit of 2h over h, which is equal to 2. No question asked. So in general, so if f of x is the famous mx plus b, it means that's a linear function, then regardless what x is, f prime of x is equal to slope, okay, because it's a linear function. So those are two basic functions. So if function is constant, the derivative is 0 because there is actually no change. If it's a line, the derivative is the slope because the derivative is nothing more than the slope of the tangent line, and the tangent line is the line itself in this scenario. Right, now I'm gonna ask, we're gonna do the following problem. So that's the only thing we can do so far. Now we are going to sketch the graph of the derivative. So the question is, we're gonna sketch the graph of the derivative. So sketch the graph. I will do the first one, and the second one, I will put it on, of course, here, and I will let you think about it a little bit. What do I mean by sketching the graph? Suppose I take a function here. And let's see how my function is. So this is, it bottoms up here. So here it's bottoms up, and that's my function f of x. That's my function. Okay, so let's assume this is, let me give it number. Let me give it number 2. Okay, all right. Now sketch the graph of f prime. It means right below it, I'm gonna have a graph. Okay, here, the input is x, the output is f of x. Right here, I want the input to be x, but the output, the slope. So that's the output. So the output is the slope at the point x. So I don't have a formula for f here, so I cannot even find f prime, but I want to have like a rough idea what is the graph of f prime. All right. How can I answer this type of questions? I'll ask you a question. Is there a point on here where we actually know the derivative? Is there a particular point where knowing the derivative is easy? Let me be very precise. If I take x equal to 2, and I'm assuming my function is bottoming up at 2, what's the derivative at 2? I go to 2, this is where the derivative is horizontal. That's exactly where the function is totally bottoming out. Okay, so at 2, the derivative is equal to 0. So here, if my input is x, my output is f prime, the derivative is 0. Now let us analyze a little bit. So that's my 2. Now I want to start asking a little bit. If x is less than 2, what can we say about the derivative? Positive or negative? That's the only thing I want. If I take a point here, or a point here, or a point here, the derivative absolutely negative. So the derivative is any point here, the derivative is going to be negative. It means if I am graphing the derivative function here, if I take any x less than 2, let me take x equal to 1, okay, the output here is the derivative. It means the derivative is going to take negative value. If I take 0, the derivative also will take negative value. If I take minus 1, the derivative is negative value. So if I take any x in here, up to here, the derivative, here the output are f prime. So the derivative will have to be negative. That's one thing. Another question is, are the derivatives, that is the slope in our case, are they getting more negative or less negative? More negative or less negative? As we get closer to 2, less negative. Everybody's telling me it's negative, it's getting less and less and less. So when I'm graphing them here, I know they are negative. Now, what you draw here, a line or a curve, it doesn't really matter. So I know that they are negative. That's the only thing I can. And they are heading toward 0. Because they are getting, as x goes to 2, the slopes are heading basically toward 2. Okay, so that's how intuitively we are going to sketch this derivative. Now, when x becomes larger than 2, in here, so here f prime, negative. That's really what's happening here. However, here, the derivative, which is the slope, is definitely positive. And they are getting more and more positive. So here, the derivative are 0, and they are getting away from 0. They're getting more and more positive, and that's how we're going to sketch the derivative. Okay, so this section, we're just going to sketch the graph. Next section, we're going to go back to formula, but now today, we're just going to sketch the graph. Okay, now I'm going to give you another example of sketching, and I want you to do it. So think about it a little bit. So let me take another piece of paper, because we have to think about it along those lines. So let me do that. Sorry. Okay, so this is my function now. Okay, and I'm gonna go like this. And then I'm gonna wiggle it a little bit and then go up. And this is my function. So the input is x, the output is f of x. Crucial now because we're changing input and output. And let me give some values here. Let me give some values here. And this is, I don't know, that seems to be -0.5. And that's it. These are my values. And this is f. Be very careful. So now f, this is, the output is f. Now down here, I'm basically asking you, how is the derivative changing? It means, how is f prime changing? So now here, my output is my f prime, my input is x. So if you guys have a piece of paper with you, or if you should, start graphing it. I'll give you a few minutes for you to graph it, and then I'll take it over. But just think about it. What are I don't know what you guys did. I wish I knew. Which are the points that you think we know the derivative immediately? Which point do you think should be our guideline in this particular problem? Anybody have any idea? Okay. 1 and 3. Is Elizabeth right? What's happening at 1? At 1, the slope is horizontal, exactly, and at 3. Those should be our starting points. So when I'm sketching here, I first put those two. They are absolutely, because they guide us. We know that the derivative is 0. And then I split. After that, I start splitting. From here to here, what can I say? What's the output for the derivative? Okay, I draw the line. I mean, that's really what I do. I draw the line in my head, not in my head. I'm drawing them on the picture. And I say, okay, what's happening to those slopes? First, are they positive or negative? So I just draw them. And the slopes, so here, the slopes are definitely positive, right? And they are actually heading towards 0. So they are positive and they are heading towards 0. So how should I graph those derivatives? How should I do them? Positive and go to 0. So when I'm graphing here, so at this point, my derivative is positive. At 0, my derivative is positive. It's getting less positive. Okay, at a half, my derivative is positive. Remember, here I'm taking the value of the derivative. So the derivatives are positive, they are positive, they are positive, they are positive, and they are heading towards 0. That's my f prime. I'm at 1 here. Now what's happening between 1 and 3? So from here to here, Oscar, what's happening here? Okay, who would like to tell me? F prime is what here? Negative. So already I know that if I take anything between 1 and 3, my derivative is negative. It means my output will have to be here. That's really what it means, because right here, the output are the derivative. This one is a bit tricky because what's happening to those slopes? The slope seems to be getting less negative at the beginning. Sorry, they seem to be getting more negative at the beginning, but then as we move on, we always move on, they seem to be heading toward 0. Okay, so they are, how can I express this? So I don't care exactly where this happened. This is something we will be studying throughout the semester. But at the beginning, they seem to be heading away from 0, that they are becoming more negative. And then at some point, they seem to change their mind and heading toward 0. That's really what's happening. They are moving away. And then at some point, they kind of change and they start heading toward 0. This is a point where we're going to give it a very specific name, where this thing changed. After that, what's happening here? What's happening here? This is the derivatives here are definitely positive. So the derivative here are definitely positive. So I take any point here, the slope, the output here are the values of the slope. The values of the slope are positive. So that's how we analyze the graph of f prime. Okay. We're going to do more, but now I'm going to take a little bit of a break, talk about an idea, and then I will come back to sketching. We're going to talk about the following idea. The derivative is a limit. So the derivative is a limit of ratio. So the derivative is a limit. Okay. And we've seen before that the limit may not exist. Sometimes a limit exists and sometimes a limit does not exist. So this means that f prime, sometimes we have an output when this limit exists and sometimes we don't when the limit doesn't exist. And this is going to bring up the following definition. So definition. Okay, we say that the function f f of x is differentiable at a point A if the derivative at A, if f prime of A exists. What does it mean f prime of k exists? It means if the limit, that's what f prime for us is, if this limit exists. Another question is when this limit failed to exist. All right, so we say that a function f is differentiable at a point A if the derivative at A exists. It means this limit. What does it mean exists? It means this limit here of the limit of the slope of the secant line. That's really what it is. Okay, we get a value, one value if we compute. So now let us see how this limit can fail to exist. In what scenario this limit failed to exist? So that's the scenario we're going to talk a little bit about. So let us see how can this happen. So how can a function fail to be differentiable? How can f of x fail to be differentiable at a point A? Means there is no way the derivative doesn't exist. All right. All right, so I'm going to take 3 examples and see what's really going on. Okay, I'll take the most prominent example, which is the following. Suppose I have a function f, that's f of x. And this is a point A. And let us say I'm going to take my function, look like that. Okay, absolute corner at the point A. Okay. Now, what's the derivative at A in this scenario? Does it exist? And let me make my scenario even easier. I assume that, so since I drew a straight line, let us assume the slope of this line that's positive. Let's say that the slope is 3, for example, just to make the scenario very real. And that's the slope here. I don't know, I'm going to pick up a number. Let's take the slope here is -2. And now, if I have a function that have this picture, what is the derivative at A? Does it exist? What do you think? Okay, look, tell me 0. And it's not correct. Look, and let's see why. Elizabeth say no. Why? What's happening? What does it fail in the limit process? Let's see what's failing. Let's see what's failing. Suppose I take h here. A plus h. Okay, watch careful what's happening. And I compute the slope of the secant line. What I'm going to get. So suppose it means basically, let me compute the limit as h become close to 0 from the positive. What does it mean? It means h positive. So it means I take a and I add something to it of f of a plus h minus f of a over h in this problem. If I do that, it means this is my a plus h and this is a. It means I'm actually asking the slope of this line. But the slope of this line is -2. Now, what happens if I take h negative? What does it mean h negative? H negative, it means h is minus point something. It means I'm taking a, I'm taking away from it. So this is h positive here. It means I'm taking a and I am taking away something because h is negative. So it's a minus. So if I do that, in this case, the slope of the secant line is going to be equal to 3. So here, the slope is going to be equal to 3. Okay. So basically, we have two tangents at this point. If you want to think about it in terms of tangent line, we don't have one tangent. From the left, this is the tangent line. From the right, this is the tangent line. So we don't have really idea of a tangent line at this point. So since this gives me that, since the left limit, the right limit, so this gives me that the limit does not exist. Does not exist. So f prime at A is not defined, or f is not differentiable at A. There is no derivative. So one of the important scenario where the function doesn't have a derivative is when the function exhibits a very clear corner at a point. The reason is I need a tangent line. I don't have one. I have one from the right and another one from the left. So that's when another picture. So the picture here is in general. Suppose here I took two lines to make it fairly clear. If I didn't take two lines, even if I didn't take two lines, if I take a picture that looks like that, so I can take it to be here, something like that, and I create a corner, I create a situation. This is a function where also the derivative doesn't exist, because if you think from the right, that's the tangent line. The slope is 0. From the left, no, that's the tangent from the left. So if I start computing the slope of the secant line from the right, I get a 0. If I start computing them from the left, I'm not definitely getting a 0, because they are getting closer and closer to this line. So I don't have a unique tangent from the left and from the right. So if I start computing those limits, I don't get the same answer. So one scenario where the function doesn't have a derivative at the point when the function exhibits a corner. For the function to have derivative, it has to be smooth. It has to be like this. That's the picture for derivatives. In other words, graphically, it means it should almost look like a line, one line all over. Here, there is no line that the function can look like. Okay, so whenever there is a corner, the function is not differentiable. Now, another scenario where the derivative can fail to exist. That sometimes can happen. It's the following, and then we summarize the situation. Suppose a function looks like this. Okay. At some point, let's say here, the function is behaving nicely, but the tangent could be almost horizontal, so something like that. And it could be horizontal. Okay, so here at 0, the tangent is, I'm sorry, I said the wrong. What did I say wrong? What did I say wrong? Anybody? I said something that's not correct. What word? Indefined. So the slope has to be vertical. So suppose at some point, the line, so this is my line, this is my curve, and at some point it starts almost vertical, That's how my graph would look like. This cause also the function does not have the derivative here because the slope actually goes to infinity. Now, are there functions that have this property? Can anybody think of a function that looks almost like this? One of the famous functions that look like this is cubic root of x. Not x cubed, it's the cubic root, because x cubed is like this. So the derivative is going to be 0. Okay, cubic root. Let me take the cubic root of x. This function has problem at 0. Let us think about, suppose I'm going to compute the slope. So let us at 0. So let us find f prime at 0. Okay, let us do that. What's the definition? It's f of x. No, it's the limit as h goes to 0 of f of x plus h, my x here is 0, minus f of x divided by h. That's the definition. And let us see what's happening here. So it's the limit as h goes to 0 of f of 0 plus h is f of h. It's the cubic root of h minus f of 0 is 0 divided by h. So it's not a made-up scenario. That's why we have to make sure that I'm not making things up. The cubic root is h to the power a third divided by h. So it's the limit as h goes to 0 of. Now let's do a little bit of algebra. H to the power a third divided by h will give me 1 over h to the power 1 minus a third to a third. And now watch what's happening. As h goes to 0, this one is going to blow to infinity. This becomes close to 0, and this will go to infinity. So the slope definitely does not exist. What's happening here, we have a vertical tangent, so the slope is not defined. So that's another scenario where the derivative does not exist. So we saw two scenarios where there is a corner and when the tangent is almost vertical. Now the last scenario, this is if the function itself, let us say the function look like this. Also, the derivative doesn't exist for the same reason. If you want to think about it, the slopes from the left, from the right are absolutely nonsense in this case. So how can f fail to be differentiable? So the function f fail to be differentiable means the derivative doesn't exist at a point A if, now this is not a 100% mathematical statement, but that's the idea. If f has a corner, very sharp corner, at the point A f of A, at the point A f of A, so something sharp corner. Understand clearly, we know that tangent from both sides are not the same. Tangent from both sides are not the same, or the secant line are not approaching the same number. In other words, if f has a vertical tangent, f has a vertical tangent. At the point A f of A. And usually for vertical tangent, either the picture should be crystal clear, you see it, or the formula will show you that. So that's another reason. So this is, and this is the graph of something like this. So this is a point A, and the function is like that. That's the exit. That's how it is. And finally, if the function like is not continuous, it means it's breaking. And this, so f not continuous at A. So these are the scenario where the function failed to be differentiable. Okay. So now let me take a graph of a function, and we're gonna sketch its derivative. Okay. So back to sketching f prime. I'll take one example. Let's see what it is. So the question is, sketch the graph of f prime. Right, I start with the first example. It's a simple one because suppose my function is the two line I took a minute ago. So that's my function. So it is like this. Let me assume this is point, let me call it a 4, and then like that. This is my function. That's my input, and that's my output. And to make the problem very precise, because I don't have a grid, let me, if you have a grid, you may be able to find the slope, and let me make up numbers. So let me, the slope here is equal to 3, and that's negative. The slope here is equal to -2. Okay, and this is where the corner happened. And now we're gonna sketch f prime for this function. How can I sketch the derivative here? So right here, the output is f prime. That's the slope. The input is x, the output is the slope. So how can I graph something like that? So first here, at 4, there is no output. So f prime is not defined at 4. So you have to notice very well, f prime at 4 is not defined. And we know how to show that something is not defined. There's no derivative. But before 4, what can you say about the derivative? So let me ask you questions now. What's the derivative at -1? If I take this point here, I tell you f prime at -1. The derivative here at 3. What is f prime at 1? At 3. F prime at 2. 3. F prime at 3. 3. So this is my 4 here. That's my 4. I'm not putting anything. As you realize, I didn't put the dot because it's not 0. But prior to 4, up to here, the derivative is absolutely constant. And its value is 3. So my derivative is constant, constant, constant. Right here, open. Why open? Because there is no output for the derivative at 4. After that, so here, after that, what's the derivative doing? So again, it's the same as before. But if I take any point here, the derivative is -2, -2, -2, -2. So it's a constant because that's a straight line. So this is -2 in here. So right here, it's not defined. That's how we show that there is no and then after that, it's -2. And that's how the graph of f prime would look like in case we have a corner at a point. In case we have a corner, the derivative is not really defined. And now finally, I can start with give you mixed match of smooth behavior. So when I say smooth behavior, the function is smooth. It means we don't have the sharp corner right there. And corner, so we can make up example like that, for example. Suppose I take this function, I let it peak and then move nicely and then go like this. And we can make up numbers. So that's a 1, that's a 3. And after that, it's a straight line. So honest to goodness straight line, there is nothing here. So this is my input and this is my output. And if I want to sketch the graph, okay, what's happening here? What would you start with? 1, 0. 3, I don't know. 3, but it's not 0. I just put it 3. Because right here, that's again a corner. And let's watch the graph. Up to 1, positive, 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 getting less positive, getting less positive, heading towards 0. So when I go down here, what are the output for f prime? This is f prime, crucial. They are positive numbers. But they're getting less positive. They are less positive, so something like that. Simple. Between 1 and 3, negative, 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 negative. I don't know what they get to, but somehow they keep negative at 3, open circle. And what happened after 3? What happened after 3? We take a value here. What's happening here? So this is f prime negative, f prime positive. Okay? What's happening here? What's f prime here? Quickly. 0, 0. So what does it mean here? It's open and absolutely 0. Means that's the value of the derivative. All right. Of course, that's it for today. As you guys know, your exam is out. I mean, I graded it last night. And if you have any questions or any concern, please let me know. You know, you can be here for my office hours and I can go through everything with you. All right. So good luck for tomorrow with your MyLab and bye for now.